Welcome. We're looking at factorization today. Quick reminder there, that is somewhere in your textbook. Factorization is the process of writing a number or an expression as the product of its factors. You will remember we talk about prime factorization and so on. But in this case, we are dealing with algebraic expressions, and we are actually writing an expression as a product of its factors. If you want, it is indeed the reverse procedure of expansion or removing brackets. Right, there are different groups of expressions, and you will be dealing with all these. I think you need to learn them one by one. For instance, you should be able to identify expressions where you factorize by taking out the highest common factor. Then there's a group of expressions where you factorize using a method called difference of two squares. Then there is factorization of expressions that are grouped as trinomials. Then there is trinomials, also a group of trinomials where the coefficient of x squared is some number a, where a is not equal to 0. In grade 9, you were only doing the first part, right? Like x squared plus bx plus c. Right, then there is factorization by grouping, and we have the sum and difference of cubes. So we're going to be doing all those things. Let us revise quickly how we factorize expressions that just require us to take out the highest common factor. For instance, we are given here 6x cubed plus 12x, and we want to factorize. Now you'll notice there are only two terms in this expression. The first thing you really need to do is to check whether there is a common factor. And comparing these two terms, you will notice 6 is a common factor. There is a 6 in the first term, and 6 is a factor of 12, so 6 is the highest common factor. Then there is x cubed in the first term and x in the second term. So what's common there is x. So altogether, that makes 6x the highest common factor. Then we draw our brackets like that. Now to get the other factor, we now need to take our expression, each term of our expression, and divide it by the highest common factor, which is 6x. So we need to take 6x cubed and divide it by 6x. And that will actually give us an answer of x squared. So in there we have x squared. The idea is when you multiply 6x by x squared, you should go back to 6x cubed. Right, then do the same thing. The 12x here should be divided by the 6x that you see there. And dividing that will give you 2. And so that will be our answer. Right, what about 3x squared minus 9y plus 12xy? Again, a close look at this one will tell you that you can just use the highest common factor method. In other words, look right across and check what is common. 3 is common, and I don't see anything else that is in all the 3 terms. Only 3 is common, and then we get x squared in the bracket. That is what you get when you divide 3x squared by 3. Then when you divide negative 9y by 3, you'll get minus 3y. And divide 12xy by 3, you'll get a plus 4xy. Right, I'm sure this is the answer. If you want to check your answers, you can now use distribution. Remember, this is just the reverse of distribution. So if you multiply the 3 inside the bracket, you should get back to your original expression. Right, here is a more complex example. We are still factorizing, and we are given here 2 terms. This expression has 2 terms, and the first thing we need to check for is the highest common factor. Do you see anything common in these 2 terms? You will notice there is a common factor. The 2 terms both have m minus 3n as common. So as it were, that m minus n is our highest common factor, so we kind of remove it or take it outside. All right. So you can imagine it like this. I'm not saying you cancel this out, but imagine that this and that have been removed and it's now out there as a common factor. The quickest way to get your answer inside the bracket is to actually take note of what remains after the m minus 3n has been taken out. So we remain with 7k and minus 3p. All right, so that should be our answer. Let's look at another example. All right, 4x is multiplied by a cubed minus 2. That's one term, plus in brackets 2 minus a cubed. That's another term. So we are factorizing. If you don't want to make a mistake, remember outside this bracket there is a 1 there. So you really can squeeze in the 1 there so that you know there is a 1. Many people make a mistake there. Right, again, you want to look at the 2 terms. In these 2 terms, as you can see, this here is a cubed minus 2, but that there is 2 minus a cubed, so these are not equal. And this is where we said in grade 9, you can change the sign and then swap those around. So let us do that. So this is 4x brackets a cubed minus 2. But we will need to change signs here. So the plus that we see there becomes a minus. So that's now a minus 1. But if we change that plus sign to a minus sign, then these numbers inside the brackets will swap positions. So now we start with a cubed and we have our negative 2. Right, now we can see a cubed minus 2 is common in both terms. So take that outside. So a cubed minus 2 is out there now. So now it's like these have been removed. So what remains if you remove that? Right, clearly you remain with 4x minus 1. Then check. Do you think you can factorize this thing any further? Unfortunately, you can't. Later on, we shall talk about difference of cubes and difference of squares. A cubed minus 2 is not really difference of cubes, although you can manipulate it and write it somehow like that, but that is not at our level for now. So this will be the answer for D. Okay, let's quickly revise difference of 2 squares, dots. Use a squared minus b squared as a rule or as an example. Now we call this difference of 2 squares because, as you can see, there is a minus sign there. That means difference. A squared is a square number, b squared is a square number as well. So this is difference of 2 squares. So as soon as you recognize that your expression is actually difference of 2 squares, all you need to do is to draw your 2 brackets like that. Then in one of the brackets, you need a plus sign. In the other bracket, you need a minus sign. Right. Then just take the square roots. For instance, the square root of a squared will give you a. So that means on the left we have a, Then same for b squared. The square root of b squared is equal to b, so we have a b on the right. So that would be the factorized form for a squared minus b squared. Right, let's look at this other example quickly. Factorize 27a cubed minus 3ab squared. Now, as it is right now, it doesn't look like difference of two squares. That is actually not difference of two squares, because I know 27 is not a square number. I know a cubed is not a square number. A is not a square number. 3 is not a square number. So this is not difference of two squares. But the first thing we do when we factorize is to look for highest common factors. So are there any common factors in these two terms? You will notice 3 is a common factor because there is 3 in 27 as well as in 3. So 3 is a common factor. Then we've got a cubed in the first term and we've got a in the second term. So what's common between those is a. And I think nothing else is common. There is nothing common about b. So our highest common factor is 3a. So if 3a is common, then what do we have inside? So take each of those terms, 27a cubed, right? Take that and divide it by 3a. You will get 9a squared. Do the same thing for the second term. You'll get a negative b squared. Now you will notice what we have inside the bracket is actually difference of two squares. 9 is a square number. A squared is obviously a square number, and b squared is a square number. So that is difference of two squares. So as soon as I recognize that that is difference of two squares, I then draw my two brackets. In one of the brackets, somewhere there in the center, I put a plus sign. In the other bracket, I put a minus sign. It doesn't matter where you put the signs. You can start with a minus and end with a plus sign. Then just take the square roots. So what is the square root of 9a squared? That will give you 3a. So 3a goes to the left. And then the square root of b squared is b. So b goes to the right. And you check that is the full factorization of this expression. You can't factorize this any further. Right, some of these expressions are actually large. Like this one here, this means the square of 2x plus y subtract the square of y. So that makes it difference of two squares. So I know straight away this is difference of two squares. So I'm going to draw my brackets, but I'm aware that this is a large expression. That's a large expression. So I'll draw my bracket like that. And obviously I need more space. I'll put a plus sign in one of the brackets and I'll put a minus sign in the other bracket. Now, do you see that I'm leaving more space to the left? That is because that expression will go to the left and it's quite large. Y squared is just small. It doesn't require all the space. All right. And then we take the square root. What is the square root of the square of 2x plus y? That will give us 2x plus y if you take the square root of that. So 2x plus y goes to the left, which means 2x plus y will also go to the left in the other bracket. And now you look for the square root of y squared, and that is equal to y. So y goes to the right, and y goes to the right. Can we simplify this any further? Yes, we can. That will give us 2x plus 2y, and that will give us 2x. But you will notice that inside this bracket here, there is a common 2 there, so that 2 should go outside now. And so we get 2 outside, and then x plus y inside, and then our 2x there. You can actually simplify that. 2 multiplied by 2x will give you 4x, so your answer can be left like this.